Namaskar. So in this lecture now we will begin to understand the concept of cells, EMF and internal resistance. So let's have a look what is the brief background. So as we had discussed in a previous lectures, like when we are trying to have a constant flow of current in a conductor, then you must supply a current, right, electric charges from some external source, and that source is your cell, from where you can supply that continuous electrons through it, and that will maintain the flow. So here let's see that how that can be done, and related to that, what are the concept of EMF and internal resistance come into picture. So let's begin. So let's a simplest cell you can assume is that electrolyte cell, where you have this kind of part where you have this electrodes inserted in that, some picture of it, and let's say it would have a electrode. So there are two electrodes, one is positive and one is negative. So let's say this is your positive and this is your negative, and see this is your the point here, this is here. So this is that where your these electrodes have a contact, the immediate contact to the electrolyte, right? Let me draw it well. So this is your electrode, P is positive, N is negative electrode, and this is your point. Let's say this is your point A and this is your point B, where they are making the electrode is making the immediate contact to the electrolyte here, your material here, right? Electrolyte. Okay. Now if you see that the potential of the P electrode, the P with respect to electrolyte, like the PA, that can be, let's say it would be B positive greater than 0, and in this case, in case of N electrode, the negative electrode, with respect to B, it would be negative B minus, where B minus is greater than 0, right? So here negative, it means that the current will flow here in this direction from N to B and from A to P, right? So let's have our external resistor for the time being here. So let's say you have a load resistor connected to these electrodes, and this is your positive and this is your negative, right? So if the load is connected a resistance R, and then a current would flow it, right? So the current direction would be what? From positive to negative. So it will flow like this, right? So it means then when it is flowing inside that liquid, so it will flow which direction? So it is outside, it is flowing in this direction, positive to negative. So to maintain the current, the continuous current to be maintained, then they should be neutralized. So the charge coming should flow from here to here, right? From B to A. So inside the current flow would be from negative, inside the electrolyte, the current would flow from negative electrode to positive electrode, and in outer circuit it will move from positive electrode to negative electrode, right? So here the concept comes, then this current would be flowing opposite to that, and their concept comes that it may offer internal resistance when the current is flowing through it. So that we'll discuss in a moment, but this is the just to give you the concept that how the current flows inside and what would be the structure of it, right? So now talking about that potential, as I said, that potential between this PA and the NB, which is the immediate contact to the electrolyte, is B plus and B minus. So the potential difference between the electrodes, PN electrode, would be what? The potential difference between the PN electrode would be B plus and then your plus minus B minus, right? So it would be the difference, right? So we are talking about P electrode potential difference between P. So with respect to electrolyte, this is having a V plus, and with respect to electrolyte, this electrode N is having minus V minus. So the total difference would be your V plus plus V minus, right? And this is what is also known as electromagnetic force, and it is represented as epsilon. You can write it electromotive force. the term force is sometimes misleading because it is actually the potential difference between the two electrodes, and the name says that it is a force. So it is the time when it was invented, it was not known that what is the phenomenon about it. So that's why the term force was given that time, but electromotive, right? So electromotive force. So that time the concept was not well known that what is how it happens. So that time the name was given. So that's why its name is electromotive force, and it is represented by asylum. So here when there is no current flowing outside, and then the total potential difference between the two electrodes is given as electromotive force, and it is the potential sum of the potential of the electrodes with respect to the electrolytes, right? So this is what you are getting here. Okay, so now to understand the significance of this electromotive force and how it works and where the internal resistance comes into picture, so let's connect resistor. So let me redraw for you again. So let's say this is your the tub, and here you have electrolytes where insert your electrodes, right? So this is your filled with the electrodes, and here you have the electrode P, and here you have electrode N, right? And this is the nearest point here, A, and this is your A, and this is your nearest point to this is B, and this is your electrolyte. Okay, so now let's assume that we have a external load R, right, and we are connected into this electrode, right? So as I said that the current will flow in this direction, or inside it will flow from this to this direction, right? From negative electrode to positive electrode, and outer circuit it will flow like P to N. Now assume that R is infinite, right? So in that case there is no current will flow, and it would be looking like that there is a open circuit. But if you calculate the potential differences, right? So the potential difference if the current is flowing here, so it would be what? It would be IR. And between these, as we have seen here, it is V plus, and here with respect to this it is minus V minus, right? Okay, with respect to this immediate contact to the electrolyte and to this plus. So now we want to calculate between this the whole circuit in this situation. So the potential difference would be between P to N can be given as what? So it can be given as a potential difference between P to A and plus potential difference between your P to A and then your potential difference, because the charge is flowing from this direction to this direction. So I'll just add up the total potential, and then plus potential difference between A and B, plus potential difference between B and N, right? So now if you see, as we discussed, the potential difference B and A is what? It is your V plus, and the potential difference between A to B is what? Let's say if it have an internal resistance R, right? So it would have a potential difference IR, and since it is flowing in the opposite direction A to B, so it would be minus IR, right? So it can be written as minus IR, small r, remember this is for the internal resistance. And the potential difference between B to N is your plus here, right? Because the N to B it is minus. So okay, so you can write like this. So now you can rearrange it. So you can have a potential difference V is equal to V plus V minus minus IR. It would mean that it can be written as epsilon, as we just discussed above, and then minus IR, right? Okay, so this is what you get. So now you can see that this is the potential difference between electrodes. Potential difference between these electrodes V and P and N can be given as like this, right? As we just saw. So this is the condition when you don't have any current flowing, when I'm assuming that R is tending to infinity. So I is equal to V upon R is equal to 0, right? But let's say if this is the R is finite, in that case what would happen? So in that case what would happen? In that case you would have V is equal to IR, right? So in that case you can just modify the equation. IR is equal to epsilon minus I small r, right? Epsilon is your electromagnetic force, so it is also written as EMF. Okay, so if you solve, then you can have the current is how much it can we have epsilon upon R plus R, right? So this is what the current is going to be, and the maximum current, if internal resistance is 0, then you have a I max which can flow through it is that epsilon by if R is equal to 0, maximum current that can flow through it is epsilon R. This is the maximum current that it can take. And so this is about how to estimate internal resistance and current flowing through it, and how to what is electromagnetic force, and actually it is a potential difference between the electrodes, and if there is internal resistance, then why it is flowing up in opposite direction in the electrolyte. So just remember the current flows in external circuit as from positive electrode to negative electrode, but inside the chemical, inside the cell, it flows from negative to positive. So this is how the whole circuit of the charge flow is balanced, and you have a continuous flow of current in our external circuit, and as well as the neutralization of the charge inside. So now you have a fair idea about electromagnetic force, the cell, and the internal resistance, and how they are related. So in next lecture we will discuss about how to connect these these cells in series and parallel, and what would be the equivalent EMFs and internal resistance, and how we can estimate. So see you there. Thank you.